Since we've been studying linear equations, it's sometimes useful to see how these linear equations relate to real-world situations. So this is an example of how that happens. It says, use the following information about a possible tax credit for a family consisting of 2 adults and 2 children. Notice that off to the side that there is also a diagram depicting the information that's expressed in these equations. For this situation, earned income is represented by the capital letter E. The subsidy, or which is basically just a grant of money, is represented by the capital letter S. And notice that the amount of the subsidy depends on what the earned income is. Something you will also see sometimes in real-world situations or real-world examples is that there's a restriction on the values that E can be for this subsidy. So if earned income can only be between $0 and $20,000 in order to earn a subsidy. The reason why that would make sense is if you look at what happens, as earned income increases, I'm subtracting off larger values, so the subsidy is decreasing. And once I get to $20,000, the subsidy becomes 0. If I was to allow E to go over $20,000, this subsidy would become negative, and that doesn't really make any sense. A negative number in terms of a subsidy would mean that they're taking money away from people, and that wouldn't be a tax credit anymore. So the upper value or the largest value that the earned income can be in order to earn a subsidy is $20,000, and the minimum amount would be 0, because again, you can't earn negative dollars. So that's why this earned value is between 0 and 20,000. So you'll often see restrictions like this on real world examples. And then the last one says that total income represented by T is basically how much you earn, E, plus how much you get from the subsidy. So what we're going to do in this question is kind of use that information to calculate or determine new information. So the first one is rather simple. It says write total income T in terms of just E. Right now we have total income in terms of earned income and the subsidy, but since we know what the subsidy is in terms of the earned income, we can replace or substitute the value of this subsidy with exactly what it is in terms of earned income. So that's all they're asking us to do. So total income will be earned income, E, plus the value of that subsidy, which is 10,000 minus 1/2 earned income. So rather than writing total income in terms of 2 variables, I can write total income as just 1/2 E, or earned income, which is what I get when I combine those like terms, plus $10,000. Okay, so this is useful if I only know a person's earned income, so I don't have to recalculate their subsidy and then plug it into a separate equation. I now have one variable in terms of a single other variable. That's why we would want to use this. Okay, so now it says find earned income if the subsidy is $6,600. Well, the equation that relates subsidy to earned income would be this equation. So I'm going to write the subsidy is equal to 10,000 minus 1/2 earned income. I know the subsidy is $6,600, so I'm going to replace 6,600 into that subsidy location, which will give me 10,000 minus 1/2 earned income. And then solve this for earned income. When I solve this, I add 1/2 earned income to both sides. I'll get 1/2 E on this side. I'll subtract 6,600 from both sides, and I'll get 3,400 over here. Multiply both sides by 2 to isolate E, and I end up with earned income is $6,800. So what that means is I'll earn a subsidy of $6,600 when I have an earned income of $6,800. Okay, so moving down, it says find the earned income if the total income is $13,800. So, there we go. The equation which relates earned income to total income is the one we found in part A. So using this equation, the total income is 13,800, so I'm going to put that in the total income location, which will equal 1/2 my earned income plus 10,000. Subtract 10,000 from both sides, I'll end up with 3,800 equals 1/2 my earned income, which tells me that my earned income will need to be $7,700 $600 when I multiply both sides of that equation by 2. That's 0. Okay, so I'm able to, from that information, determine the other information. It says find the subsidy if the total income is $12,500. Well, I'm not going to use this equation because it only rates total income and earned income. So I'm going to go back up to the top. Find the subsidy if the total income is $12,500. Well, so far I only have subsidy in terms of earned income, so I'm going to first have to find what the earned income is and then plug that back into the subsidy equation. So I know the equation which represents total income in terms of earned income is the one we found in part A. So I'm going to plug in total income and first find earned income. So that'll be $12,500 is my total income, which is replacing the T in this equation. So equal 1/2 my earned income plus 10,000, which tells me that 1/2 my earned income, when I subtract 10,000 from both sides, will be 2,500. So that earned income is $5,000. Well, once I know what my earned income is, I can go back to my equation for subsidy, which is in terms of earned income, and calculate what my subsidy will be. So S will equal 10,000 minus 1/2 E. So this is 10,000 minus 1/2 my earned income, which I just found out was 5,000 in this example. So the subsidy will be 10,000. Should that be at 10,000 minus 1/2 5,000? So my subsidy is, well, half of 5,000 is 2,500. So 2,500 minus 10,000 will give me $7,500. And that's what my subsidy will be, $7,500. So the main thing to take away from this example is that we can use equations that relate to each other to calculate a good number of things. We could rewrite equations in terms of one variable given something in terms of multiple variables. And there are sometimes restrictions on equations. So with this information, I want you to take a look at question 95, work through that question. It's slightly different, but it uses the same kind of reasoning skills.